Welcome to your mathematics class. I want to believe you're preparing fully for your BECE exam. Alright, we're going to be looking at 2020 BECE past questions. It's divided into three sections. You have section A, section B, and section C. So we're going to have seven series. We're starting with series 1. But before we start, I want to remind you that if you have not subscribed to our YouTube channel, please do so. My Simple Maths on YouTube. And you also need to click on the notification button if you want to get alerts each time we post a new video. Alright, let's start. Question 1 says express 0.0000400089 in standard form. Alright, so if we're expressing in standard form, we want our decimal point to be moved to this point. Yes, it should be between the first whole number and the next number. So we're going to look at how many times I would have to move before my decimal point gets to this point. So let's go. This is 1, 2, 3, 4, 5. Right. But because we have 0.000, that means it's going to be a negative number. So we're going to write it as 4.0089 times 10 raised to power minus 5, because it's actually in decimal, so our power is going to be negative. So this is the answer for this. The next question says approximate the budget of 358879461.97 to the nearest million. Alright, to do this, we need to know the place value for each of those numbers, isn't it? Alright, so this is your tens, this is your hundreds, this is your units, tens, hundred, thousand, tens of thousand. Is that okay? Hundred of thousand. And then this is your million. Did you see? So this 8 is our million, and they said to the nearest million. So if this 8 is the million, you look at the number after it. If it's 5 or more than 5, that means you add 1. So this is your million. Okay, so because this is 8, I'm going to add 1 here, and all other numbers become 0. Is that taken? And that's why I have 359, because this is my million. So I'm adding 1 to this to give me 359, and then every other thing becomes 0. So this is 359 million.00 is this budget to the nearest million. Is that okay? Very good. Question 3. Which of the following numbers is not a perfect square? When you say perfect square, you're talking about a number that requires you to multiply another number twice, the same number twice. So let's express all of these as perfect square. This is 64. 64 is 8 times 8. That makes it a perfect square because I'm multiplying 8 by itself. 81, 9 times 9, that makes it a perfect square. 100, 10 times 10, that makes it a perfect square. 120, 12 times 10, these two numbers are not the same, so this is not a perfect square. 121, 11 times 11. So of all these numbers, 120 is the only one that is not a perfect square. Is that taken? Good. Question 4 says, find the LCM of 30, 45, 60, and 90. Okay, so I'm going to arrange all those numbers here, and then I'll start dividing by the smallest prime number I can use. Is that taken? So I'll start with 2. So if I say 2 in 30, that is 15. 2 in 45, I can't get a whole number, so I'll just write my 45. 2 in 60, 30. 2 in 90, 45. Okay, I can still go with 2 again. 2 in 15, it can't give me a whole number, so I'll write 15. 2 in 45, 45. 2 in 30, 15. 2 in 45, I'll still write out my 45. Okay, so 2 cannot divide any of the numbers again, so I'll move to 3. 3 in 15, 5. 3 in 45, 15. 3 in 15, 5. 3 in 45, 15. Okay, then I'll divide by 3 again. 3 in 5, I'll write down my 5. 3 and 15, 5. 3 and 5, I'll write down my 5. 3 and 15, 5. Okay, now I have 5 all true, so I can divide by 5. 5 and 5, 1. 5 and 5, 1. 5 and 5, 1. 5 and 5, 1. The aim is to ensure that we have 1, 1, 1, 1 all true. So now I've found the LCM. What is left is for me to write out all these factors I've used in dividing the number. So I'm going to write them out. I have 2 times 2 times 3 times 3 times 5. This is it here. So I'll multiply. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 5 is 180. Is that taken? So the LCM is 180. Right. The next question says simplify the square root of 144 divided by 3. So that means I have to find the square root of 144 first. So what is the square root of 144? 12. Because if I say 12 times 12, I'll get 144. So the square root of 144 is 12. And now I will now say 12 divided by 3, which will give me 4. So this is my final answer. Do we understand this? Very good. The next question says subtract 10101 base 2 from 11110 base 2. So since this is what I'm subtracting from, I'll arrange this first. 11110. Then what I want to subtract from it, 10101. Now when you're subtracting or when you're working with your binary number, it's important that you arrange them accordingly. Arrange them accordingly. So this has been well arranged. I can now start subtracting. Okay, if I say 0 minus 1, that will not be possible, so I'll have to borrow 1 from here and bring it here. Remember, the one I'm borrowing is actually 2 because I'm working in base 2. So 2 minus 1 will give me 1. Okay, I borrowed 1 here. I'm left with 0. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. And so my final answer is 01001 base 2. Is that taken? Very good. Okay, so if you need more explanation on this topic, you can check our YouTube page for the topic binary number. You get more explanation in that. Alright, let's move forward. Number 7. If 5 men can paint a wall in 3 hours, how many men will paint the same wall in 3/4 hours, working at the same rate? Now, what you should understand is, when you're talking about men working in a particular number of hours, you should know that the more men you have doing the work, the lesser time it will take. So if I have 5 men doing 3 hours, well, if I have more men, I'm going to spend lesser time. Do you understand? Alright, so let's look at this. If 5 men can paint a wall in 3 hours, that means 1 man will paint the wall in 5 times 3 hours, 15 hours. You should expect that if 5 men can take 3 hours, that means 1 man will take more than this hour. So that is why 1 man is taking 15 hours. Now, if 1 man takes 15 hours, then the number of men that will take 3/4 hours will be this 15 divided by 3/4. Do you understand that? 1 man can take 15 hours. So to know the number of men that will take 3/4 hours, I'll just say 15 divided by 3/4. And then I'll change my division to multiplication. My denominator becomes my numerator, and my numerator becomes my denominator. So 15 times 4 divided by 3. Is that taken? 15 times 4 is 60 divided by 3. 60 divided by 3 is 20. So what this is trying to tell us is that 20 men would take 3/4 hours to do the same work at the same rate. Is that taken? Good. Question 8. Simplify 3/100 plus 33/100 correct to 1 decimal place. So what I need to do is to change this to decimal. So if I say 3 divided by 100, that means I'm moving my decimal places 2 places to the left, and that will give me 0.03. And then 33 divided by 100, the same thing, I'll move it 2 places, 1, 2, and that will give me 0.33. And then I'll add these two together. This will give me 0.36. But remember, the question says to 1 decimal place. So this is the 1 decimal place, and because the number after it is 6, I'll add 1 to this, and that will give me 0.4 to 1 decimal place. Is that taken? Very good. Question 9. Simplify 0.5 times 1.5 times 2 as a single fraction. So what I'm going to do is to change all of them to fraction. Then I'll now simplify. So 0.5 is the same thing as saying 1 over 2. 1.5 is the same thing as saying 3 over 2. And then 2 is the same thing as saying 2 over 1. So I'll multiply. By the time I multiply, 1 times 3 is 3. 3 times 2 is 6. 2 times 2, 4. 4 times 1, 4. So 6 over 4. But I can still divide further, isn't it? 2 can divide both numbers. 6 divided by 2, 3. 4 divided by 2, 2. So 3 over 2 is the single fraction. Is that taken? Very good. Okay, in case you're wondering how you can do this, you just say this is the same thing as saying 5 divided by 10. I'll just move my decimal point here and say 5 divided by 10. And this is the same thing as saying 15 divided by 10. You get this fraction. Is that okay? Very good. Question 10. We're still working with binary number here. Multiply 101 base 2 by 11 base 2. Remember, in your binary number, the only numbers that is permitted is 1 and 0. Is that taken? So 101 multiplied by 11 is just like your usual addition or your usual multiplication. The only thing is that your numbers should not exceed 1 and 0. Is that okay? Alright. 1 times 1 is 1. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. Then I'll add. 1 plus 0 now is 1. 0 plus 1, 1. 1 plus 0, 1. And then this is 0 plus 1, 1. So my answer is 1, 1, 1, 1 base 2. Is that taken? Good. Alright, this question says express 3 over 4 as a decimal. So my 3 is going to be here. I'm dividing it by 4. 4 in 3, it cannot go, so I'm going to write 0. And then this 3, I'll add 0 to it to give me 30. And then I'll put my decimal points. Each time you're adding 0 here, you put a decimal point. Okay, so now I've added 0 and I've introduced my decimal point. Then 4 in 30 is 7. 4 times 7, 28. 30 minus 28 is 2. And then I add my 0. 4 in 25. 4 times 5, 20. 20 minus 20, 0. So 3 divided by 4 is 0.75. So I've changed this fraction to decimal. Is that okay? Good. Alright. Express 2211 base 4 as a denary number. Anytime you see denary, they're talking about base 10. So you have to change this base 4 number to base 10 number. Alright, so I'm going to write down my number 2210. And then I assign powers to them starting from this number here. And then I'll assign 0 to this. 1, 2, 3. Remember, we're working with base 4. So the next thing is I'm going to multiply 2 by the base raised to power, whatever power is on this 2. And I'll do that for all of the numbers. So I'll come here 2 multiplied by this 4 raised to power 3. And this is what you have here. 2 multiplied by 4 raised to power 2. This is it. 1 multiplied by this 4 raised to power 1. 1 multiplied by this 4 raised to power 0. So I have all of that written here. Alright. The next thing is, what is 4 raised to power 3? That is 4 times 4 times 4. That's 64. So 2 times 64. 4 times 4, 16. 2 times 16. 4 raised to power 1 is still 4. 1 times 4. Now, any number raised to power 0 is 1. So even if I have 22 raised to power 0, it's still 1. So 1 times 1. And then I do my multiplication. 2 times 64, 128. 2 times 16, 32. 1 times 4, 4. 1 times 1, 1. And then I had 128 plus 32 plus 4 plus 1 will give me 165 base 10. Remember to write your base 10. Is that taken? Very good. Question 13. Find the square root of 750 divided by 1080. Alright, to find this, it's good you reduce it to its lowest form before you find the square root. Alright, so I'll look at it. What can go in these numbers? I'll start with 5. So if I say 5 in 7, that's 1. I'm left with 2. 5 in 25, that's 5, and then 0. Then 5 here, 5 in 10 is 2, isn't it? Or let's say 5, okay, yes, 5 here 2, and then 5 in 8 is 16. I'm left with 150 over 216. Alright, what else can go? 3. 3 in 15, 5, and then the 0. 3 in 21, 7. 3 in 6, 2. I'm left with 50 and 72. What can go? 2. 2 in 50, 25. 2 in 72, 36. Now I can find the square root of 25 and 36 because they are perfect square. Okay, so square root of 25 is 5 and square root of 36 is 6. So this is the square root of 750 divided by 1080. Is that okay? Very good. Question 14. Which of the following angles cannot be constructed using a ruler and a pair of compasses only? You have 45, 60, 90, 115, and 120. Okay, so angle 45 can be constructed using your ruler and pair of compass. All you need to do is to bisect angle 90. Angle 60 can be constructed with your ruler and compass only. Angle 90 can also be constructed with ruler and compass. Same thing with 120, but 115 cannot be constructed using a ruler and compass only. You have to use your protractor for this. Is that okay? Very good. Question 15. Richard walks a distance of 4 kilometers to school in 1 hour. How far can he walk in 5 whole number 1 over 2 hours? Alright, so let's try to equate these two information. If 4 kilometers is equals to 1 hour, then s kilometer is equals to 5 whole number 1 over 2 hours. Then we cross multiply by saying x times 1 is equals to 4 times 5 whole number 1 over 2. So x times 1 is s kilometer. Then 4 times 5 whole number 1 over 2. You can change this to improper fraction. 2 times 5, 10, plus 1, 11 over 2. Okay, so 2 here 1, 2 here 2, or you can just say 4 times 11, 44 divided by 2. 44 divided by 2 is 22 kilometer. So Richard can walk 22 kilometer in 5 whole number 1 over 2 hours. Is that okay? Good. Alright, question 16 says the surveyor bearing of 300 degrees is equivalent to a compass bearing of. Now you need to know the difference between a surveyor bearing and a compass bearing. For surveyor bearing, you're just given the number and the degree. That's all. But for compass bearing, you need to show the direction, maybe north, south, west, east, whatever. So you have direction and the angle in your compass bearing. Alright, so let's have a diagram to illustrate that. If this is my north, my south, my west, my east, and I have a bearing of 300, so you know that from here to here is 90, from here to here is 180, from here to here is 270. So for me to have 300, that means I will have 270 plus 30, that will give me 300. So if the whole of this is 360, and I have these as 300. That means this remaining part is going to be 60 degrees. So this is 60 degrees. To know my compass bearing, I'll look at the direction. I have north, I have west, and I have a 60 degree in between them. So to read this, I will say north 60 degree west. North 60 degree west. That is the compass bearing. Is that question 17? What is the bearing of B from A in the figure below? So in this figure, you have the bearing of A from B to be 25. Alright, to get the bearing of B from A, we need to put our cardinal points on this point B2. So if this is 25, this will also be 25 because this is an alternate angle. Then the other angle here is going to be 65 since the whole of this is 90 degrees. So this will be 25, this will be 65. Now the bearing of B from A will be this angle from here up onto this line. So this is 90, this is 180, this is 270, and then I'll say 270 plus this 65. That will give me 335. So the bearing of B from A is 335 degrees. Question 18. Calculate the bearing of B from A in the diagram below. Calculate the bearing of B from A. Alright, so this is the bearing of A from B, 220. To know the bearing of B from A, I'll put my cardinal point here. Alright, so if this is 220, I know this is 180, isn't it? So this point is going to be 50. Do you understand? This is going to be 50. So if this is 50, that means this point is going to be 40. Is that taken? This is going to be, because we know that 40 plus 50 is going to give me 90. So if this is 50, that means this is also going to be 50. So if this is 50, then this will be 40. Is that taken? So the bearing of B from A is 40 degrees. Question 19. Simplify 3 over 2 of 1 over 3 plus 4 over 7 times 7. So we're going to use our board mass. We're solving the brackets first. I'll bring out the numbers in the brackets. 1 over 3 plus 4 over 7. The LCM of 3 and 7 is 21. 3 in 21, 7. 7 times 1, 7. 7 in 21, 3. 3 times 4, 12. 7 plus 12 is 19 over 21. Then I'll write 3 over 2 of 19 over 21 times 7. Then the next thing is I'm going to do this up. Up is the same thing as saying multiply. 3 over 2 multiply by 19 over 21 multiply by 7. Is that taken? Alright, let's look at what can go. If I say 3 here 1, 3 here 7, 7 will cancel out 7. I'll be left with 19 divided by 2. So 19 divided by 2 will give me 9 whole number 1 over 2. And that's my final answer. Question 20. Express a commission of 15 naira on every 200 naira as a percentage. So I'll just say 15 naira over 200 naira times 100. 100 here 1, 100 here 2. 15 divided by 2. And that is 7 whole number 1 over 2%. So this is expressing 15% as a percentage of 200 naira. Okay? Alright. So this will come to the end of this series. Don't forget to subscribe to our YouTube channel, My Simple Math, and click on the notification button so that you will be aware each time we post a new video. Thanks for listening and watching. Have a nice day. Bye.